So good morning once again. No? So this is the sum program, the summation program, which I converted from the fourth factorial. Okay, do you follow? Now there's a way to do that, to do this directly, no, without having to go through the addition of each number one by one. You can just add 4 plus 3 plus 2 plus 1. Okay, but the version I'm trying to do here is a version that will prepare you for the looping version, no? The loop, the version with the loop, because we are going to compute the average of the three numbers, no, later. Now one of the items is to compute for the average of the first three numbers, no. Do you follow? So I'm trying to create a version in preparation for that, no? So anyway, so like the factorial program, kasi this is the factorial program. No, we start with n00411. Okay, so that we are doing the same. Okay, now S004 is our next addend, okay, which is 4, and then 001, which we initialize to 1, is our decrement, because we will decrement every now and then. We will decrement in order to compute the next addend. For example, if our current addend is 4, the next addend is 4 minus 1 becomes 3. And currently our partial sum is 1. The final answer will be in ST002, the 002 of the store. No? We don't have any other variables used. No? Okay. Now the first operation is times, because we are going to initialize the first sum by multiplying it to 1. So we are going to multiply ST002, which is our partial sum, with ST00, which is 4. Okay. 1 times 4, and 1 times 4 is 4. Do you follow, everyone? This is our assignment, no? This is the answer to our assignment. So we will store the partial sum by S002. So our partial sum is now 4. Do you follow? Okay, can you see my worksheet? I hope it's clear on your side. Okay. So dito na tayo. The next thing to do is to compute the, sorry. The next thing to do is to compute the next addend. Okay, the first addend is 4, the next addend is 3. How do we do that? The previous addend, okay, which is 4, will be loaded. So we have L000, which is 4. Then L001, which is the decrement. 4 minus 1 is 4. Okay, we have that. And we store it to 4 minus 1 is 3. I'm sorry, no. Okay. 4 minus 1 is 3. We'll store it as the next addend, which is now in 000. This is not. Do you follow? Okay. We're tracing a program here. Now the next is to compute the next sum. The next sum is 4, the partial sum, which is 4 here, plus the current addend, which is 3. Do you follow? Okay. So we have a plus L of 002, which is our partial sum, which is 4, and 000, which is our next addend. We know it's 3. Well, it's very clear, it's 3 here. Okay. So 4 plus 3 equals 7. Okay. And we store it to 002, which is our partial sum also. So the next sum is 7. Okay. We follow, everyone? Now, after computing, we compute for the next addend, because it's still 3. We stop with the last addend being 1. Okay. When the last addend reaches 1, we stop. That will be our final sum. Okay. So minus L000, which is the current addend, no, 3. Okay, 3 is 3, no? Sorry, I'm sorry, no, it moves. It's 3 here. I'm using the keyboard, no? No. So we put it here. L001, we know it to be 1. So if you subtract this, 3 minus 2, 1 equals 2. And we store it out to 000, which is the next addend. We do not stop because our next addend is still 2. So since being a 2, we will now compute the next partial sum. Okay, the next partial sum is plus the previous sum, which is 002. We know it to be 7. So this is 7. And the next addend which is 2. We load it here. So 7 plus 2 becomes 9. And we store it as the new partial sum. So this now becomes 9. Okay? Do you follow? So little by little, we are trying to compute the sum of the first 4 numbers using partial sums. Okay? Now, our current addend is still 2, so we will compute the next addend. So L of 002, which is 2. 2 ito ngayon, no? And then 001, which is always 1. So 2 minus 1 is 1. So we'll stop. This is being the last, no? We'll stop when it's 0, by the way. And S000, so the next addend is 1. Okay? Still being a 1, we will load the partial sum, which is in 2. The partial sum is currently 9. We will add it with 00, which is the next. This is 1. And we will store the partial sum to our variable in 2. So this becomes 10. Okay. And we stop. Okay. Because our partial sum is already, our next addend is already 1. So you have a P, B, and H. P means we are going to print the answer to the last card, the next consecutive card, and B will ring a bell, and H is out. Okay. So very easy, no? Okay. How do we convert this to compute the average? Okay. How do we convert this to compute the average? Anyone? No? We'll do the same. We'll just start at 3 and we will store a divider at the beginning. The problem with this is our divider, which is 4, is lost. No? Our next addend, which was initialized to 4, cannot be used at the end because it's lost. We do not have the number 4 anymore. Do you follow? Do you follow? It's lost in the process. So what we are going to do is to store an extra variable. So we are storing the extra variable to 3. Ito na yung addend, no? Ito na yung average. So we are using the variable 3, st. Dati hanggang 2 lang tayo. This time we are going to use the variable 3, st003, to store the final divisor for the average. And initially it's equal to the first addend, which is 3. Okay? This is no different from the computation of the first 4 numbers because we'll just compute the sum of the first 3 numbers the same way, which is eventually shorter, and then we will divide the partial sum, the final sum, with the divisor 3. Do you follow? Okay. So N003 is 3. This is the next addend. N001 is 1. This is our next, this is our next the constant decrement. And N002 is 1, which is our partial sum. And our average divisor is in 3. Do you follow? We will just keep this in memory so it doesn't get lost. We will use this in the final part, in the final step, to divide the final sum. Okay. Okay. So anyway, the first thing to do is a times. This is just like the partial. This is an initial step which we use to first compute the initial sum. The partial sum is 1, and we compute it we multiply it with the first addend, which becomes 3, and we store it to 3, to the 002, which is now 3, which indicates that our first partial sum is 3. Okay, we'll start with 3. Okay, any questions so far? Okay, now the next thing to do is to compute for the next addend. The next addend is 2. So what we will do is load L00, which is 3, minus the decrement. This is 2. Let us erase the others. Para trace natin properly. We can trace properly. Okay. Okay. So we have 3 minus 1 becomes 2. So the next addend is 2. Now, having computed the next addend, we are ready to compute the next partial sum, which is 3 plus 2. It's 3 here and 2 here. Okay. So we do a plus, load L002, which is 3, and L002, which is, rather 0, which is 2. And 3 plus 2 is 5. And we load it as the next partial sum. So this now becomes 5. Okay? You follow? And then 2 is not our final addend. 1 should be the final addend. So we compute, we load, we minus and load 0, 0, 0. 0, 0 being our next addend, which is previous addend, which is 2. The decrement, 2 minus 1 is 1. Do you follow? And we load it to L0, 0, 0. So our next addend is 1. That will be our final. Having computed, okay, the next, we are going to load our partial sum in 2. This is our partial sum. So this is in 2. So we load it. Okay, and we will load the the next addend. The next addend is in 0, 0 is 1, which is here. And we plus, so this becomes 6. We store it as our next partial sum, which is 6. Okay. Now we have the final sum, which is 6. What we are going to do is divide this. Okay. We have 6. So we are going to load it. We'll do a divide, load it from 2, which is now 6. Now finally we have L003. That's the main reason why we had L003, because if you have, without it, we cannot remember anymore what will be the divisor. Okay, 6 divided by 3 is 2. And we store it to 2. So 2 is our answer. So we have a PBH. Okay, do you follow? The average of the first 3 numbers is 2. 3 plus 2 plus 1. Okay, 6 divided by 3 becomes 2. Any questions so far? Okay, I'm having some sore throat here. Medyo, excuse me a while now. Okay. Any questions? Now we are going to do it with with a loop, right? Anong oras ba tayo matatapos? Hanggang 11 ba? I'm keeping track of the time na. Because I don't have an AIS, I cannot seem to access anyway. Okay. 10:50. We have 50 minutes more, okay? So let's do the average with the loop. Now, I'd like to look at the, kasi I have a little correction with the computation of the, sorry, mali. Bakit nawala na yung aking ano? If you open this in your end, no? Bakit nawala yung aking ano? But I'd like to, nahihirapan yung aking ano, my internet is slowing down, I think, no? I hope it's not slowing down in your end. Hindi ko makikita yung aking, unfortunately, I cannot get. Basta the run-up lever is like this, no? The run-up lever will set if the last sign, you have to look at the egress axis. If the sign of the egress axis is not the same as the sign of the ingress axis, it will do a set. So for example, when you say 1 minus 4, 1 minus 4 will not do a set. 1 minus 3 will not do a set. Can you open this site, no, on your end? It's there, no? And look at the run-up lever, ito. You can open it from our Dagler site. Fortunately, I don't have one, so I cannot open. But anyway, what's indicated there is this, no? The moment 1 minus 4 will not set, 1 minus 3 will not set, but 1 minus 1 will set. Why is that? Because 1 minus 1 is 0. No? Starting from 0 to negative, The sign of the 0 is not the same as the sign of positive 1. Do you follow? So it will do a set. Okay? Do you follow? That's why in the average with the loop, we'll do a test. No? We will do a test, which is a minus. Okay? If it is 1 minus 1, okay? For example, if it is 1 like this, no? 1 minus 2, 3. If you have 1 minus 2, no? The sign of the egress axis is negative 1. The sign of the ingress axis 1 is positive 1. So they are not the same. So which means we will go back. We will do a reset. A rather set. Okay? Do you follow? Please look at the source, no? I cannot open the source from my end. I'm sorry, no? Hindi pwede. We just have to believe me, no? That a set will be done if they have 1 minus 1. Okay? Or 1 minus 2. Okay? When the sign of the ingress axis and the egress axis are not the same. Okay? This is the average of the first 3 numbers. Okay? Let me erase this. Ito na lang muna. Hanggang dito tayo. The good thing about this loop version is that we can use this program to compute for the average of any set of numbers. We just change the 3 to the desired number. For example, if you want to compute the average of the first 10 numbers, gawin na lang N0003 and then N000. This is not 00, this is N003. I'm sorry. Okay, because that's our average divisor. Okay, the same thing we are going to store our average divisor so that it doesn't get lost, because eventually if you don't store it here, it will get lost. Is that correct in my first version? Tama, no? We follow? And then first compute the we compute the partial product. So we do a times of the current partial product, or rather partial sum, which is 002, and then 00, which is 3. So 1 times 3 is 3, and we store it as here as 3. Do you follow? No? We don't have this anymore. Bakit meron tayong S004? We store it at temp, no? Okay. We'll find out later, no? But anyway, we'll delete this if it's not. I don't think this is needed, no? We'll delete this later, okay? For the moment, we don't know what the use is. Ginagamit ba yung 4? Let's look at that. Walang ginamit yung 4, oh. So most probably we don't need this, okay? We don't need this. We'll erase that later, no? So, we now have our first partial sum, which is 3. The next thing to do is to compute for the next addend. Okay. So the first addend is the current addend is 3. So we the partial we load the current addend, which is 3, and the decrement of 1. Okay. So 3 minus 1 is 2, and we store it to 0, 0, 0. So this becomes 2, which means our next addend is 2. Okay. Any questions so far? Very easy now, because we are going to do a 3 plus 2. So we proceed with the plus. L002 is our previous partial sum, which is this. So we load it here, and we add the next addend, which is this. No? We add it here, so this becomes 2. 3 plus 2 is 5, and then we store it to our next partial sum, which is 5. Do you follow? Now this is the check. We load L001. L001 is 1, and we'll check with our next addend, which is 2. Okay, so 1 minus 2. Okay, 1 minus 2 is a negative 1. Do you follow? So what is the sign of the egress axis? It's negative 1. What is the sign of ingress axis 1? Is positive. They are not the same. Do you follow? Since they are not the same, Okay? We will do a set. Okay? Pag hindi sila pareho set, ito. You can look at the no? You can look at the reference if you're not sure, no? Because the 1 minus 2 will do a set because the sign of the 1 minus 1 will not do a set. Do you follow? Only 1 minus 1 will not do a set. Okay? I don't have the no, but since this is negative, no, and this one, so they are not the same. We will move CB 11, which means we will count 11 times. One from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we will go back here. Instead of overwriting them, we are going to go into a pass 3. What I did is I copied all this, no, ito, copy ko ulit hanggang dito for the pass 2. For the second pass. So hanggang dito rin sa, it will end at the PBH here. Do you follow? Do you follow? Now I have a grade computation example bala, no? Afterwards, no? Let me, please remind me that. Because somebody asked for a CF, an example of a CF. Okay, and anyway, before we proceed, let's look at the values, the previous values, no? Our next addend is 2. Okay, our decrement is 1. Our partial sum is, what is our partial sum? It's 5. Our previous addend is 2, no? Our partial sum is 5. Okay, so we'll just repeat to compute the next addend. Okay, the divisor, what is the divisor? This is 3. Okay, I hope you can see everything, no? Kaya ba? Okay, is it clear? Is my worksheet clear? Okay. So we minus to compute the next addend. L00 is 2. We have it here, no? And then L001, which is 1. 2 minus 1 is 1. Okay, and we store it all to L000, which is our next addend is a 1. Okay, so we will compute the next partial sum. We load L002. L002, the previous partial sum is a 5. We add it with the next addend, which is 1. Okay, 5 plus 1 is a 6. And we store it to L002 here, which is a 6. Do you follow? Do you follow? Any questions? No? So now, we will again check. Okay, we will again check whether to proceed or not. So L001 is 1. L00 is L00 is what is L00 now? It's a 1. The next addend. 1 minus 1 is a 0. Okay? Do you follow? So this will not do a set. Okay? This will not do a set because the 0 and 1 are the same sign. Okay? So what we will do is we will not go back 11 steps further, but we will just continue. Do you follow? We do a divide in order to compute the average. L002 is currently 6. L003 is a 3. So 6 divided by 2 is a 3. Tama ba? 6 divided by 3 is a 2. And we load it as a final answer, which is a 2. And we do a PBH. Okay? Do you follow? So we really don't need this, no? Meron talagang hindi kailangan. Okay. Do you follow? Do you follow? So I hope you know how to compute for the CB and the CF now. We just compute the egress. Look at the sign of the egress and the sign of the ingress axis 1. If they're not the same, it will do a set. If they're the same, it will do a reset. So it will just go on. Any questions so far? Okay. Okay. The next is the computation of Celsius to Fahrenheit. You can use any number in Celsius. Now, in this example, we are trying to convert the value 200 degrees Celsius into Fahrenheit. Okay, this is straightforward computation. No, what we'll do is to compute the formula is multiply times 9 divided by 5 plus 32. Do you follow? You can Google that. No, it's just the reverse. So N002 is 200, this is our Celsius. And then 9 is our multiplier. 5 is our divisor. This is 5 here. And 32 is our addend, final addend. Let's erase this. Okay. Do you follow? No? So what we'll do is load the input value from 000 to 200. Ito, 200. And multiply it with 009, which is 9. Okay. Okay, so 200 times 9, that becomes 1,800. Any questions? That's very clear, no? And then we store it to 000 here, no? So this becomes 1,800, okay? And then we do a divide of 1,800 with L002, which is 5, okay? So we'll just compute this. That's 360, okay? And we store it to L0000, so this becomes 360. Do you follow? And then we'll add the 32. So this becomes 360. 32, what is the value in L? This is 32. So we'll just add 392. And then we store it to L000. This is 392. So 200 in degrees centigrade or Celsius is 392 in degrees Fahrenheit. We do a EBH. It exits the whole code. Okay, without loop ito na, with wala talagang loop ito. Okay, any questions? Okay, so we have a without loop. Sorry. I'm sorry. Excuse me. Let me rename this. Di pala pwedeng yung ano. Okay. There's a with loop. No? Okay, we have a centigrade to Fahrenheit. Okay, any questions? Now, I'd like to show you an example involving CF because somebody requested no, to do a CF. What's the difference between CF and CB? CB means move backwards. No? This is a combination card. Count backwards. No? CF means move forward. Okay? Any questions? Malayo pa tayo, no? So let me show you that example. This is the grade computation example. Okay. I will upload this now to Daigler. Let me erase this first. What we will do here is we will convert a raw score from an exam no, into a grade. And we will determine whether the grade is passing or failing. Do you follow? So passing means 1, failing means 0. Do you follow? And our passing cutoff is 75. Okay, we will store the final result in 9, no? Dito. The final result, whether passing or failing. Do you get my point? No? So, the formula for computation is score over items, okay, times base minus 100 minus base. Score over items times 60 plus 40 plus base, no? Do you follow? Diba? Score over items, okay, times 60 plus 40. Score over items times 100 minus base plus base. No? Quantity 100 minus base plus base. Do you follow? No, ganyan yan, no? S over items times 100 minus B plus E. Ito yung formula, no? Ito yan. Score over items times 100 minus base plus base. Okay? That's how to convert a raw score into a grade equivalent, a numeric grade. Okay? So ito yan. First, we will store the base in 000. Okay? We will store the example here is 80. Okay? And then we will store the score in 001 and the items in here. And the computed grade will be stored in 003. Okay? 100 is our 100 minus base ito para hindi mawala. And then passing is 1 and failing is 0. Okay? And the passing cutoff, let's say cutoff. The passing cutoff is 75. Okay? They follow? If it's 75 and up, we will say it's passing. If it's below 75, we'll say it's failing. Do you follow? No? So first we will divide the score over items divided by L001, which is 80, and the items is 100. So we will divide this with this. Okay, that's 0.8, and we store it to 003. So this is our grade, 0.8. No, partial grade. No? Okay. Score over items. Okay, and then we will what minus the base. No. So minus L004, which is 100. Okay, 00, which is the base, 40. So this becomes 60. And we store it to 007, which is our temp. Temp ito. Okay. So this is now 160. Okay. What will we do with the 60? We will multiply it with the 0.8. Okay. With the partial grade, which is 0.8. The zero base grade, which is 0.8. So we'll do a times L003, which is 0.8. Okay. 7, which is 60. So we'll have equals this times that 48, and we'll store it here at 003. Our partial grade is 48. Okay. And then we will do a plus 40. We'll add the base, right? So we have 000, which is the base, 40. And L003, which is our partial grade, this is 48. So our final grade is 88. We'll store it here. So the equivalent grade of 80 is 88. Do you follow? Now we will determine whether this is passing or failing. Obviously, it's passing. So L006. What is 006? We assume first that it's failing. 0. Okay. L005. 005 is passing, which is 1. No? With times we store it at 009, which is the result. We'll say 0. We assume that it's failing. And then if not, then we will correct it no later. Okay? We assume it's failing. No? Then we will do a test L008. What is L008? Our cutoff, 75. No? And 003, which is 88. I-minus natin. 13. Okay? Sandali. Yes, 13. So which means this is passing. Do you follow? This is passing. 88 is above 75, so this is passing. Dapat 74 pala, no? Kasi 75 minus 75 will not, yeah, okay na yun. 75 minus 75, that's passing. Okay, it will jump, no? What will a 75 minus 75 do? Kasi 1 minus 1, 1 minus 1 will proceed, will set. Okay? Tama ba ito? Otherwise, we'll just change this, no? Ligtarin natin. Kasi 75 minus 88, we're supposed to go backwards. So since this is negative, we'll go to 4, we will forward here. Okay? Yes, so we'll multiply 5 by 5 and we'll store it to 1 and this becomes 1. So this is passing. Do you follow? Passing siya kay 88 man and then we'll do a PBH. Any questions? Okay. It will jump because it is magkaiba sila. Okay. It is a set. Okay, it is a set. 2 divided 13. Magkaiba sila eh. Inside. Any questions so far? Now, let's check if this is let's check for a failing grade. No? What's a failing grade? Let's say it's 50. Yeah, 50. Okay. 0.5 plus 4. 50. 0.5 ito. This becomes 0.5. 30. 30, di ba? 40 plus 30. I hope you follow, no? 40 plus 30. Now, what we're trying to do is trace this again, no? 50 yung score natin. So this becomes a 0.5 instead of a 0.8. And then 100, this is still a 60. 0.5 is our, zero-based grade times 60. That's 30. So this, our partial grade is 30. We add it to the base, 40 plus 30, which is 70. So this is now 70. Our numeric grade is 70. Do you follow? Do you follow? Okay. So ang temp natin is 60. Okay, because we have added it here, no? Multiplied it here, so no problem now. So we have 70. We assume it's a failing. Okay. And then this is a 70. So 5. What will happen? 70 and 5 are of the same sign. Do you follow? So this will not do a set. It will just move forward. What will it do? It will just print, bell, and halt. Do you follow? At this point, it will halt. It will not proceed this anymore because it's a halt. So the final grade is failing. You get my point? Everyone? Any questions? This is recorded now. You can review this. Unfortunately, I don't have a diagram. I'll have to check it later. Okay, any questions? Okay. So I will upload this in Daigler 2.0 as soon as I have access to the I think I have to fix my network. Okay. Any questions? That's the assignment. If you have
Sir,
yes.
question sir ba? Mag-move forward lang siya sir pagkuan. Dili same ang signs.
Yes. Kapag mag-move forward siya if the signs are not the same, yes. It will move backwards or forwards if the sign of the egress and the sign of the ingress are not the same. So
Kung same sign siya sir kay mag-stop na ang kuan ang program.
It will not skip. It will not skip. Do you follow? Kasi kanina 88 ito, di ba? So negative 13. They're not the same sign. So this will skip 4 times. 1, 2, 3, 4. Do you follow?
Yes sir, hello sir.
If they're not the same, it will skip. If they're the same, for example, 70. The egress is positive, the ingress is negative, or positive also. So it will not do this. It should skip. Do you follow?
Yes sir.
Print Abel and the halt. Just like in our in our average, okay? So average with loop. Average with loop. Let's look at that now. Ito. Do you follow? Okay. Okay. 1 minus 2 is a negative 1. This is a negative 1 and this is a 1. They're not the same. So it will move 11 times backwards. Do you follow? Kasi negative 1 ito. This positive 1. They're not of the same sign. It will go back 11 times. 11 steps. Do you follow? Unlike here, no? Unlike here in pass number 2, when you say, in pass number 2, we say 1 minus 1 is 0, right? 1 minus 1 is 0. So they are the same sign. Okay. They're of the same sign, so it will move forward. Okay. It will not go back. Did I answer the question?
Yes, sir. Thank you, sir.
So 1 minus 1, it will not skip. Okay? Pag 1 minus 1 na, it will not skip. Because the sign of the egress and the sign of ingress access 1 are the same. Okay? We will end up early today, no? Kasi I will not introduce a new topic. But before that, no? Okay? Before that, what did our programs are like this, no? We computed average, we computed the fourth factorial, we computed meters to feet, or we can even compute feet to meters, no? And centigrade to Fahrenheit, Fahrenheit to centigrade. For sure, you can think of many applications of the analytical engine. They follow. But during those times, no, when Charles Babbage introduced this to the computing community, mostly scientists and mathematicians, they are not convinced, no, that this is a working machine. They even think of Charles Babbage as someone who's not on the right mind or crazy, because this was a very new invention, and he was trying to convince that this is a computer which can update its own value. This is a machine which can change its own value as it's uh, processing the cards. No? You see, you can update variables, and the scientists and the computing the scientific community during those times are not convinced. No? There's only one person who was convinced. He was Countess Ada Lovelace. No, Ada Byron Lovelace. No. So in order to prove that the analytical engine is a useful machine, Ada Lovelace created programs, no? Wrote programs. And what did she write? There are many programs, and the most important program that she wrote was the Bernoulli series. Okay? What's the Bernoulli series? Let's Google that. That's in Wikipedia, no? How do you compute the nth Bernoulli number? For example, the first Bernoulli number, the second Bernoulli number. Do you follow? So there's a formula. Okay? For any n, which is odd, no? For example, n of 0 is 1. The Bernoulli number 0 is 1. For any number in the series, such as n is odd, for example, the third binary series in the the third Bernoulli number is 0. The fifth Bernoulli number is 0. The seventh Bernoulli number is 0. But if it's even, no? There's the formula, okay? Ito yung formula. It's called the power of sums, no? Ang tawag nila dati, summe potestatum, okay? It has nothing to do with potatoes, no? But this is in Latin, okay? So this is the formula to compute the nth number in the Bernoulli series. It's very difficult, no? Do you follow? And then during those times, when you present a technical paper, no? You present it in Latin. So ito yung Bernoulli series, oh. The first number, the second number, the third number, sorry. Can you see that? Let's go back. The third number, the fourth number, that's the formula. Obviously, you can compute this by hand, no? But if you are going to write a program on the analytical engine with a loop, okay, that will compute for the nth Bernoulli number, this you should be very smart, no? You should be very smart. Okay? Why? Here is the program by by Ada Lovelace. She's going to compute the nth Bernoulli number. So the first card is a times, no? The variable involves V1 and V3. You are going to multiply the second store to the third store. Okay? Times V1, V2, and V3. And then you are going to store the result in 4, 5, and 6. V is the store. V means variable. Do you follow? And then she's going to compute for V2 and V2. And the results are shown. Where did she show the result? In 21, 22, 23, and 24. Do you follow? These are the results. This is a transcript or the blueprint of Ada Lovelace program in the analytical engine. Do you follow? So if you are going to compute for the 24th Bernoulli number, you will have this. The 25th Bernoulli number. These are the working variables. These are the data. This is found in store 2, store 3, store 4, 5, 6, 7, 8. This is the store. And the variables are in 11, 12, and 13. There are many other programs that she wrote, but the most popular was the computing the nth number in the Bernoulli series. Well, what is used, it's a lot of uses in mathematics, even until today. No? What's the use of the Bernoulli number? It's the sum of powers. Kasi it's, okay, sa may potestatum. You're going to compute the sum of powers. No? Do you follow? So yun yung ginawa ni ano. And then it awakened the scientific community. No? The work of Ada Lovelace awakened the scientific community. They're beginning to show interest into Charles Babbage's work. In fact, no, there was a lot of communication between uh, Ada Lovelace and Charles Babbage. So ito, Ada Lovelace made suggestions to improve or made to improve the analytical engine so that it can be used better, no? So they had letters, no, and then Charles Babbage thanked, no, Ada Lovelace for the work she did to prove the worthiness of the analytical engine. So ito yung letter ni ano ni this is the letter by Charles Babbage to Ada Lovelace. Okay, it was in English, but the handwriting during those days are very difficult to understand. But this is in English, no? And then she explained a variable card, maybe doing this and do that, no? He made recommendations on how to use, okay, the analytical engine better, okay. Now Ada Lovelace became very popular. Did you follow? Together with the analytical engine, no? She even became more popular than Charles Babbage. Just like today, no? Microsoft became more popular than Intel. Okay, Intel made the computer, Microsoft made the program. Okay, so during those days, no, uh, people who are following their work even uh, predicted that in the end, no, Ada Lovelace will take over the analytical engine and put it into actual work, which means because Ada Lovelace is rich, no, she has the capacity to build the engine herself, while Charles Babbage is only waiting for government funding. Do you follow? So, unfortunately, no, Ada Lovelace passed away at a very young age, no, because of some sickness. No, she died at 36. No, very young, very smart lady who died very young, and it was a very bad news during those times because after Ada Lovelace died, nobody paid interest in the analytical engine anymore. Nobody showed interest in the analytical engine, and the technology died slowly until Charles Babbage's death in 1871. There were so few improvements, no? People even predicted that had Ada Lovelace continued to live, a long life, no, a full life, we could have enjoyed computers, no, after during the First World War. No, maybe I could have a Android during my kindergarten, but she died early, so the technology died. It was rediscovered in 1950s, only in 1950s, no. It was rediscovered by Alan Turing. Also, another smart mathematician discovered that the work of Charles Babbage and Ada Lovelace is very significant and can be used to build new computers. Okay, do you follow? What else do we need to know? Now, let's look at the Wikipedia on the predecessors of the, or rather the descendants of the analytical engine. What followed? The analytical engine. Ito, no? It's in our site, no? It's on our Daigler site. No? So the difference engine was invented during 1832, not built until 1990s. And then the analytical engine is 1837, no? What's the uh, number system used is decimal. It's a mechanical machine, no? It's decimal system. It's not binary. And then the programming is done by punch cards. It's Turing complete. What do we mean when we say it's Turing complete? Alan Turing made a criteria on determining whether a machine is finite or not. When we say Turing complete or Turing finite, it is a machine that is perfect. No? Ibig sabihin, it's like a computer program without a bug. No? When a machine is Turing finite, it means that the behavior is completely predictable. No, all the branches are explored. No, all the branches, the if then else, no, are explored, which means it can really be put into actual work. It's fully working. In other words, do you follow? That's by Alan Turing in 1950s. No, the memory used is a physical state of wheels. Now, Ludgate, after the death, who's Ludgate? He's another inventor. No, tried to English inventor. Okay, he died after World War One. He's also an Irish, no, in Ireland. Tried to invent a portion of the analytical engine. Okay, it was never complete. Also, it's decimal, mechanical, and instead of using wheels, no, it uses state of rods. We don't know how it looks like. Now, in 1939, no, just before World War One, World War Two, okay, Europe and Germany were in the state of preparing for the war, and they were making machines to encode their messages, no, to encrypt their messages so that when they send messages to their troops in the field, they will not be understood by spies who intercept them, di ba? So meron sila. And then in Germany, Konrad Zuse invented what is supposed to be a replica of the analytical engine, no? But this time, this is a binary floating point number. It's not decimal anymore, no? So in 1939, uh, it was controlled by tapes na. Okay? The programming is done by 35 tapes, like cassette tapes. No, very small, 35 they're like cassette tapes. No, unfortunately, it's not Turing complete. It uses the technology of Ludgate to store memories, no? State of rods. Iron rods ito, magnetic na ito. Do you follow? Whether positive or negative, no? Magnetic na. And then bomb. Who's bomb? Bletchley Park Bomb. That's the name of the inventor. Invented a machine in 1939 from Poland, and they later transferred it to to UK. No, it's electromechanical. It's not Turing complete. The main purpose is to decrypt messages from Enigma machines. What are Enigma machines? These are encryption machines made by the Nazis. No, so that when they send messages, they will first encrypt it using an Enigma machine before sending it to their troops in the front line. So the English, on the other hand, tried to decrypt, no, the messages for intelligence purposes. No, okay. So this is not considered to be a computer, but it has, no, the physical state of rods. No? Now Z1 was the first, by the way, no, first generation computer. You know? By 1940, Conrad Zuse invented, okay, an improvement of the Zeus machine. No, by 1940, it's binary floating point, but this time it's electromechanical. In fact, if you look at this, it already has a motor. Wala siyang picture, no? But the Z1, I think, already has a motor, no? Ito, meron siyang motor, oh. This is the Z1, wala pa ito, no? This is the Z1. Okay. Now, instead of rotating gears, it uses rods, iron rods. Do you follow? That's the main difference between the Z1 by Conrad Zuse and the analytical engine by Charles Babbage. No? Physical state of rods. That's why it's like this. No? Kaya ganon. Masyadong maraming rods. No? This is the Z1. Okay. Okay. Any questions so far? Okay, we're about to finish. No? Anyway, very short. Z2. Now, in May 1941, Conrad Zuse developed an improvement. No? Another version of the Z1 is called the Z3. It's in principle Turing complete. That's the main difference. Okay? Ito yung Z3, oh. It's smaller than the Z2 and the Z1. In 1942, during the beginning of the war, no, uh, Atanasov, John Vincent Atanasov and Clifford Berry, taga saan ito sila? They're from the US. No? Uh, they invented, okay, from which man, no? They sold this, no? Oh no, they were not able to sell this one lang. Clifford Berry from Durham, Iowa State University. Okay, from Iowa State University, they finished or they invented a, a calculator. It's called considered a calculator because it's not a computer, no. But linear systems that are used to compute linear systems, no, using punch cards. And this is the first machine which uses a regenerative capacitor memory, semi-electronic na. Okay, okay, random access, almost the same. This is the same technology that we use for our memory today, no. Instead that the capacitors then are vacuum tube capacitors. Do you follow? They're not the same capacitors that we have today. They are vacuum tube capacitors, no? But it's the same concept, no, of the memory architecture, no. And then Colossus Mark I was invented in the UK, no, for decrypting also Enigma machines, no, in the UK. It's not Turing complete. It's program controlled by patch cables and switches. This is binary and electronic. Since then, no, most computers are in binary except the one invented by in Harvard, no, Mark I. Tanas of Very John Van Vincent. And ito si this is John in cooperation with John Van. Hindi ito si Neumann ang inventor. Developer. Developed by Howard Aiken, no? Howard Aiken is from IBM and he developed the Mark I in uh, in Harvard University. This was first developed only for Harvard University. It's a mechanical computer. Do you follow? It's a mechanical computer almost similar to the analytical engine, the design of analytical engine by Charles Babbage. In fact, it's also decimal. Do you follow? So mechanical relays are like you see this on a vehicle in a horn relay. Pagpusong ng magnetic ito, no? Okay, this is used for memories. Unfortunately, this is not Turing complete. Okay, now the Mark I is very important because by Harvard because it contributed to the computer jargon. No, 11:50, 5 more minutes. No, the bug was coined in the Mark I when a moth was caught in between the gears. That made the Mark I to dysfunction. No, it stopped operating because a bug was computed, or rather, it was caught in between the gears, and then they called it the bug. No, nowadays when you say bug, we mean an error in a computer program. It was first coined in the Mark I. Now, Zeus Z4. Okay. Zeus C4 was invented. This is the first in 1948. Very popular, no? It's very popular. Which was the first commercial computer? Let's look at that, no? I think C4. Yes, Z4 is the first commercially produced computer, which means it was really sold at the market. You follow? Z4, no? Mechanical relays. It was the first commercial computer. It's already binary, electromechanical, and it's Turing complete. Do you follow? Okay, Turing complete. And in 1946, after the war, the ENIAC was introduced in the US. This is like also Charles Babbage analytical engine, except that this is electronic. Okay? Vacuum tube na, no? Electronic na. Yung Zeus C4 is electromechanical. Do you follow? However, the ENIAC, we will discuss this in detail, no? Electronic numerical integrator and calculator. This is in Penn State University, no? Pennsylvania, kung saan nagtapos si Donald Trump. Okay, do you follow where Donald Trump finished, graduated college? In 1946, we will discuss this. No? This is Turing complete. The main problem with this is it's decimal. Then finally, after the war, Manchester Baby is also binary. No, this time this is binary electronic. No, okay. This is electronic stored program concept. This follows von Neumann's architecture already. No, we will introduce von Neumann also. No, and this is the first computer with a keyboard. Binary program entered into memory by a keyboard. Do you follow? There's no monitor yet. So if you ask, what is the first computer with a keyboard? It was Manchester Baby. Do you follow? Any questions so far? No? 1948. First electronic stored program digital concept. The stored program concept was invented by John von Neumann. No? In Penn State ba? Basta, we will discuss that no later. No? John von Neumann is the next most popular figure. Una, you have Charles Babbage, then you will have Ada Lovelace, then you will have Alan Turing, and then you will have John von Neumann. No? The first four. No? John von Neumann is considered to be the father of modern computing. He is even more popular than Charles Babbage. No? Even, I think, more popular than Alan Turing. No? Okay. Manchester Baby, the first binary electronic computer with a keyboard. Okay? Any questions so far? It's 10:50. Exactly 10:50. Okay? Now I have already discussed the assignment, so there's no need to resubmit. What will you resubmit? My solution? Okay. We will not allow resubmission when we discuss the answers already. I'm sorry for that, no? So see you everyone next meeting, no? Next meeting is Tuesday. Okay? Any questions? I will upload this, no? I will upload this in our Daigler site. I will try to fix my Daigler today. I think I know what's wrong, okay? Thank you, everyone. Okay, thanks for coming. I have to exit because it's already time, no? See you
Thank
next
you,
time.
sir.
Okay.
Thank you,
Salam,
sir.
sir.
Bye,
Thank you,
sir.
sir.
Thank you,
Salamat.
sir.
Thank you.